Complete automation of end-to-end testing, harnessing the power of robotics process automation and test automation within a DevOps++ framework. So this brief video is going to talk about how robotics process automation, or RPA, can be introduced alongside end-to-end test automation. This automates the boring and repetitive logistical work that often slows testers down, while also optimizing the test development work they do for both speed and quality. First, some definitions. I'll be using test dev to refer to the testing activities that focus on actually testing new functionality in the system under test. For instance, creating test cases, test scripts, and test data, as well as executing these new tests against the application. It is within the world of development where test automation, as has been traditionally conceived, has grown and evolved, focusing particularly on automating test execution. I do not include test maintenance, logistical test data management tasks, and environmental provision in test dev, as these are activities that surround and facilitate test execution. They are necessary for rigorous testing, but it is the development of complete test cases and data that can most drive up testing rigor. So these rule-based, process-driven tasks are instead categorized as test ops. So test ops includes all the often repetitive tasks that testers must perform to actually create and execute test dev artifacts. It includes tasks required as part of a team or organization, such as updating fields across centralized project management tools, keeping in communication with team members, customers and managers via email or chat tools, and so forth. These are all invaluable tasks that are paramount to being a good tester, but are all surrounded and largely auxiliary to the bread and butter of executing tests against the system. It is in the world of operations in which robotics process automation, or RPA, initially grew. RPA refers to the use of non-invasive bots that perform rule-based tasks otherwise performed by a tester. By a human. This typically involves workflows that work in the background to rapidly execute repeatable tasks. So having grown in the world of development and operations respectively, test automation and RPA harness similar technologies, and test teams are increasingly looking to RPA to automate additional processes alongside test automation. If you look at some of the surveys and reports on testing trends from the past year, you'll often find that RPA is up there alongside AI in terms of technologies that testers are either adopting or plan to adopt. This is what we are considering today, discussing how VIP can help introduce RPA to handle the boring and repetitive jobs, while also aiding test teams in creating higher quality test dev assets faster. So, say I've decided to start automating both elements of my test dev work and also the repetitive operation tasks that facilitate that development. I cannot just down tools, halt and test cycles to implement end-to-end automation. Instead, I'm going to weave automation in gradually by accurately replicating the heavy lifting otherwise done by humans, performing the same tasks in the same way as those humans. In other words, I want to automate what I do, how I do it, where I do it, but ideally faster and with some of the quality gains that can be realized by using computers. So VIP, the high performance process and test automation framework from Curiosity, provides a one-stop shop for automating both test dev tasks and test ops tasks. Both are executed using high-speed, non-invasive bots that work invisibly in the background, while a range of out-of-the-box and custom connectors mean that processes are performed across existing tools. Once a task has been automated once, it becomes fully reusable and can be exposed in a common technology such as Slack. This is what we see on the left-hand side here. Testers can leverage the efforts of previous sprints by invoking a complete test pack in Slack, which will then create an up-to-date set of test cases and data, spin up an environment and execute the tests, all while keeping the tools and teams at their organisation updated. Starting with the top row, the test dev tasks that testers perform to test new functionality, the VIP test modeler provides a model-based approach to automatically generate rigorous automated tests and data from easy-to-use flowchart models. This replaces many of the slow and frequently suboptimal manual test dev tasks that I, as a tester, might otherwise perform. Instead of having to manually analyze, requirements to formulate test cases, I simply maintain a centralized model. Business process models can quickly be imported to the flowcharts, as can existing tests using a range of connectors and a UI recorder. This removes the time otherwise spent analysing disparate and often low quality requirements in order to convert them manually into test cases. So the flowchart model of the system under test is mathematically precise, serving as a directed graph. Automated algorithms can therefore be applied to identify paths through the model, just as GPS identifies routes through a city street map. These paths from the start to end points are equivalent to test cases. Rather than having to write out the often repetitive test steps one by one, I can use the VIP test modeler to automatically generate tests from the model. What's more, I can apply sophisticated coverage techniques to drive up testing quality, reliably generating tests that cover all the logic in the system model. If I'm pushed for time, I can optimize these tests for time and risk, generating tests that cover new or critical functionality more, while still executing the rest of the model as much as possible. The model of the system under test further provides a central place for finding and making test data. This is the third pink box you can see. A comprehensive range of data generation functions are defined either at the flowchart level or separately in Excel. They are resolved dynamically as tests are created, generating data with which to execute every test required. Instead of having to manually find, make or refresh test data, I can set up the functions once and then let it be dynamically found or made for me as the tests are executed. Standard Excel connectors and additional VIP connectors allow existing data to be called and manipulated, making sure I have accurate data that reflects the very latest version of the system under test. VIP workflows can further be created to automatically spin up the environment before executing tests in using new or existing frameworks. If a good automation framework is in place, I'll only need to set up a lightweight process to connect into the existing tools. If no automation is in place, VIP can use Selenium or Appium to execute tests. Run results are furthermore fed back into the model and into existing tools, closing the feedback loop. The result is end-to-end automation of test dev tasks rather than just automating test execution at the expense of introducing slower manual scripting and leaving test case design and maintenance untouched. These test dev tasks are all performed as one-off labours in the VIP test modeler, using the VIP workflow engine to execute them at high speed as reusable tasks. Looking next to RPA, the second row, the same workflow engine non-invasively performs a repetitive, rule-based tasks that facilitate testing but often slow testers down. VIP will analyse and aggregate data from numerous sources, including emails and chat, and will likewise move information between systems, files and tools. It will maintain data across a range of platforms. For instance, if test cases are stored in HPLM but run results in Jira, VIP will simultaneously store the test case information in HPLM fields but update the run results in the relevant fields in the relevant Jira tickets. This replaces the need for testers to repetitiously copy and edit data across tools, allowing them to focus instead on developing test assets to test new and evolving logic. VIP can similarly be used to automate the internal communications that are necessary for a functioning test team, but can replace repetitious manual processes. For instance, email reporting and alerts can be set up to notify managers or test teams of progress, while task scores can be automatically updated to assign tasks as tests are created and executed. The goal of RPA then is to perform the broader tasks that facilitate high-speed, high-coverage testing, doing the heavy lifting for you. The third row is what we call DevOps++, which refers to how VIP connects up existing tools and technologies to maximize their value and remove the need to manually convert information from one technology to the next. This underpins much of the efficiency gains in test dev and test ops automation, as it means that a task performed once in one tool can be mirrored in all the interdependent technologies. This not only reduces the manual effort required of testers, but improves the information flow between systems, enabling a greater amount of data to be collected during testing and used in future to inform testing decisions. You can see some of the tools that VIP connects into on screen. So today we're not going to look at how this works in practice, but rather focus on the principles. If you have a look at our YouTube channel or the resources section of the Curiosity website, there are plenty of demos there showcasing this approach in action. So, what are the benefits of introducing RPA alongside test automation that focuses on more than just automating test execution? To summarise what we have discussed in this approach, RPA invisibly performs repetitious test ops tasks and keeps data aligned, turning rule-based processes into reusable automated workflows. Meanwhile, intelligent test automation increases the speed and quality of the test dev work by automating and optimizing tasks that surround test execution. And finally, DevOps++ enables end-to-end automation and full dependency mapping, connecting into existing tools, closing the feedback loop, and improving alignment between business and IT. So, in terms of the benefits, firstly, the combination of RPA and complete test automation means that testers have more time to focus on developing test assets to test new functionality. This is because RPA handles the test ops tasks that facilitate testing. Meanwhile, the test dev tasks they do perform will be performed more efficiently and with higher quality test assets created. This is by virtue of being able to generate and maintain optimized test cases, data, and automated tests from easy to use visual models in a structured way. When we then add in DevOps++, this further drives up efficiency by reducing time spent manually moving information between tools and enabling teams to reuse one another's efforts and also the efforts of previous sprints. Meanwhile, the greater degree of connectivity between tools enhances communication and collaboration, reducing errors and delays by extension, and also closing the feedback loop. Results can automatically be fed back into the model, updating tests accordingly. So this all means that testing gets faster and more rigorous the more you do it, when often factors like technical debt and the degree of manual test maintenance required during each iteration means that the opposite can be true. So to summarise the core principles of this approach, what we're doing is performing the same processes faster and better by introducing VIP in the background. Every business has a process that underpins their daily activities, not just testing teams. They often rely on people to manually update them. That's time and energy focusing on processes, not business. We introduce automation which mimics the work undertaken by a human, like inputting information from a PDF into Excel. What you'll find is that your bots organise information and do the repetitive heavy lifting for you. Soon you'll have enough structured data flowing through your systems to reimagine and improve other business processes, or, like we're focused on today, specifically testing processes. You decide what to automate and we help scale your business. And in turn that means more time on your clients or your testing activities, test dev work, and less time on test ops work like maintaining spreadsheets and tools. So just a quick comparison of a typical iteration from the test dev perspective with and without VIP. So without VIP, testers at many organisations begin by haphazardly trying to work out what impact a change made by dev might have across a massively complex and disparate system. Some effects are inevitably overlooked and go untested, but it is often these integration errors and upstream or downstream dependencies that cause the worst defects. Next, the testers are then faced with all their existing test cases and data, some of which might have been rendered invalid by the change. They spend ages checking and updating thousands of repetitive test cases by hand, or simply let the invalid tests pile up. However, this throws up defects that are found in the tests themselves, not the code, sending developers on a wild goose chase to fix these phantom errors. Next, the test data and environment needs to be refreshed to reflect the latest changes, creating further slow, complex and manual labour. This includes copying and refreshing data, creating new data scenarios not found in production, and refreshing test environments. The tests then need to be executed either manually or using automation. However, test automation often introduces the need to write scripts or engineer fiddly keyword-driven frameworks. So as we've been discussing, VIP introduces end-to-end automation to test dev work beyond just the execution phase. When a change in requirements comes in, testers can quickly import the new requirements to an existing model and also update test cases which are optimized for time and risk. They can generate new test data at the same time as the test cases, resolving data functions dynamically and connecting into existing databases to make sure they have the data that reflects the very latest system to execute every single test. Finally, they can invoke a reusable workflow to spin up a new test environment and automatically execute the test in an existing framework or using VIP. As seen, we can even set up a workflow to do all of this really once the central model has been updated. So a quick summary of some of the process-driven, rule-based test op tasks that VIP can automate that enables testers to focus more on developing test assets to test new functionality. This includes writing test teams and managers on chat tools like Slack or by email, as well as adding bug reports in tools like Jira and maintaining task lists in tools such as Trello. With VIP, we introduce high-performance robots that mimic these tasks, working invisibly in the background to execute them across existing tools. Again, more time to focus on testing new functionality and less on repetitive processes. So to summarise then what we've been talking about today, introducing robotics process automation alongside complete test automation means that testing with VIP is rigorous, with every possible scenario covered by test data and test cases. It is efficient with automation of tasks that surround automated execution. This includes test generation, data definition, comparing results, and test maintenance. Testing is flexible and reactive, using central models to quickly maintain tests as systems or business requirements change. Testing is structured and measurable, with expected results clearly and fully defined, and mathematical coverage techniques to know exactly what is being tested. Testing is plugged into your existing world, automating end-to-end testing across existing files and tools, rather than requiring you to halt testing cycles to introduce greater test automation. Testing becomes collaborative and VIP is easy to use, with individuals working from the tools that work best for them and sharing their one-off efforts as reusable tasks that can be invoked from a common technology stack such as Slack. So thank you very much for watching and listening. If you'd like to learn more, we have lots more resources. Please visit curiositysoftware.ie, check out the resources section of our website, or otherwise look on our YouTube channel for further videos, including some how-to demonstrations of what we've been talking about today. And please do not hesitate to get in touch with any questions, any feedback, or if you'd like to request a demo. We'd love to hear from you on info@curiosity.software. Thank you.